right, guys, let's get at least halfway through this here today, and then we'll do something a little bit different. Now, what we're doing today isn't any different or more difficult than what we did yesterday. Because the first thing we're talking about is showing that two triangles are similar by side, side, side. Now, we're not saying that the sides are congruent. We're going to say that the sides are all proportional. So if the proportions of the corresponding sides are all the same, if they give us the same fraction or reduce down to the same fraction more likely, then we can say that the two triangles are proportional to each other. And that's all we need to be able to do. Now, is either triangle DEF or GHJ similar to ABC? So we're going to compare it to triangle ABC. So most likely, triangle DEF and triangle GHJ are not going to be similar. They're not going to be similar to each other. One of these two is similar to triangle ABC. Which one do we think out of DEF or GHJ is similar to ABC? DEF. So if we find this similarity, so we can start off by saying AB is similar to which side? For DE. Yeah. Now, we're able to cheat a little bit with this because, as we see on the screen, AB's length is what? 8, yes? And they colored it. They colored it what? Red. And if we look at DEF, well, the number 6 is also colored red. Now, one of the other ways we can look at it also is that the sides are proportional to each other. Yes, we're going to increase them or decrease them all by the same amount. Yes? So if one side is the smallest in one triangle, its corresponding side should be also the smallest for the other triangle, because we're not going to increase one side by 20 and then decrease another. No, they're all going to all increase or all decrease. So the smallest side in this triangle here should still correspond to the smallest side in this triangle here, as well as this one here. And the biggest side for one triangle is still going to correspond to the biggest side of another, if they are similar. So here, AB and DE are both the smallest sides for both of these triangles. Now AB is 8 and DE is 6. You're welcome. Now we need to reduce this down so that we can be able to compare the side lengths easier. Now we can do this in a calculator or we can do it by hand. Now we notice that 6 and 8 both have a common factor of 2. We can reduce top and bottom by 2, which gives us 4 over 3. Now that we set this up this way, because we put AB on top, all the other side lengths for that triangle ABC, need to go on top, because we need the proportions to be the same so that we're not mixing the numbers up. Well, the next one we can look at is, say, BC. And BC is going to be over EF. Well, we do have the colors, but if we look at BC, the length of BC is 12, yes? It's bigger than 8, but is it bigger than the other side? Is it the biggest side? No, because we have 8, 12, and 16, yes? 12 is in the middle. And if I look at DEF, out of 6, 9, and 12, the middle side length is 9. So that means it's going to connect with EF. Because 9 and 12 both have a common factor of 3, which would reduce our 9 to 3 and 12 to 4. Well, we only have one more set of sides, AC and DF. Well, if this is going to work, our side lengths need to reduce to what? 4 over 3. Because if they don't reduce to 4/3, they're not similar. And there's a good chance, especially on the homework, they'll do this, where they'll get 2 of the side lengths that are reduced and will give us the same fraction, and the third won't. Now AC is, and DF is 12, yes? 16 and 12 have a common factor of 4, yes? 16 divided by 4 is, 12 divided by 4 is, do we have the same proportion for all of these here? Yes. So that means that these two triangles are, so triangle ABC is similar to triangle DEF. ABC, DEF. And we follow the same path. Questions on this here? Now, most likely is ABC going to be similar to GHJ? Probably not, right? Let's go on and just look at it with the side lengths. So for ABC, we have the side length of 8, which is the smallest, yes? What's the smallest for GHJ? 8 divided by 8 is 1. Let's look at 16 next. ABC has a side length of 16, which is the biggest side lengths for GHJ is? Well, that's promising, isn't it? We do have two that reduce to the same amount, yes? Let's go on and finish it out. Another side length in ABC is 12. This does not reduce to 1, yes? So are they similar? No. And again, it's good to check all three just to make sure they don't do that. So those two triangles are similar. Questions on this here? So is either PQR or STU, either one of those two triangles, similar to VWX? Well, I know this is half the statement, mainly from just what the directions told us, yes? Because it's saying which one of these two triangles is similar to VWX. So we know one of the two triangles that's going to be similar is VWX, just from the directions. So if I pick a side from VWX, what can we pick? 12, yes? And we used the letters on the first one just to get an idea of what we're comparing, how are we connecting these two together. But for the homework, we can really just look at the numbers because we're talking about the side lengths, yes? Comparing the corresponding sides. Do we want to look at STU or PQR first? PQR. And the biggest side for PQR is 16, and we're using it because we grabbed 12, which is the biggest side for triangle VWX, yes? Now we can reduce these because they do have a common factor of 4, because 12 and 16 are both multiplied by 4, and we would get 3 over 4. What's another side from VWX? What side would that connect to with PQR? 8 and 12 do have a common factor of 4, yes? If I take a 4 out of 8, I'm left with? No, because we have 3/4 and 2/3. Those are not the same. So those don't work. This one doesn't work. So now we can test the other one. So I'll grab 12 again. And 12 would be over 30. 12 and 30 have a common factor of 6. Because 3 does work, but 2 also. Because 6 times 2 is, and 6 times 5 is 30. 2/5. So what are we expecting this other one to come out to be? 2/5. So what are we going to put 8 over? Now 20 and 8 have a common factor of 4. So 2, yes. 2 is right, but it's actually, we have a second one. Now, I'm going to do that. Let's do 2. Because if I take a 2 out of 8, I have 4. If I take a 2 out of 20, I have 10. Another common factor of 2, which gives us 2 fifths. Those are the same. Yeah, because the other side is 8 over, which we reduce to 2 fifths. So this would be STU. And they kind of gave it to us in the directions, how we can set up the similarity statement. VWX, VWX, STU. Or we could have said UTS. Either way, because it's still following kind of the similar path because of 20 and 20. Those two angles would be congruent. Any other questions on this here? In the diagram, which of the 3 triangles are similar? Write a similarity statement. Now this one here, they didn't give us any hint as to which 2 we're really looking at or trying to choose between. So there's different ones we can choose. Give me one side length to start with. 39? So we're starting off with our XYZ. Whoa. Okay, so we can look at XYZ and STR. Now 39 is the smallest, middle, or biggest? Biggest. So for RST we need so 33. Now there is a greatest common factor of 3, because it's kind of hard to see once the numbers get bigger. So we can pull it out. Well, 33 divided by 3 is, okay, so we have 13 over 11, and that is as far as that goes, because 11 and 13 are both prime. Okay, we need another set of sides from those 2 triangles. 36, which is the middle side. And if we look at the middle side of RST, it would be 30. Well, again, we'll go into both. Okay, they're not similar. And we can stop there because, again, the scale factor, how these sides compare for all 3, have to all be the exact same. So as soon as I hit 2 that aren't, they're not. So we know that these 2 are not going to be similar. Yeah, so we can do LMN to RST or RST to LMN. So give me one of the 2 sides, or one side from both of those 2 there. We say 26 over. Okay, 26 is the biggest, yes? And for, are we looking, yeah, so XYZ, we wouldn't use 36, we would use 39, because we're looking for the biggest side. Now this one here, the common factors that they have might be a little hard to see, because it's not one we're used to. Y'all know what it is? Not 3. 13. 13, because 13 times 2 is 26, and 13 times 3 is 39. Yeah, so, because 13 is kind of hard to show on 2 hands, but 13 is the common factor between those. So the next set of sides we can look at is 24 over 30. 6 will go into both of those, because 6 times 4 is 24, and 6 times Those two aren't similar. So we've said these two aren't similar. We've said that RST and LMN are going to be the ones that most likely are similar. Now let's go on and show it so that we do know that it's true. I won't do that because that's a whole lot of work for nothing. And it will, and just based off of this question here, which of the three triangles are similar? It's telling us most likely if there wasn't, they would have put comma if possible. Now for the last one here, 26 over 30, because 30 is the biggest side for RST. No, 33 is. So we'd have 26 over 33. And 26 over 33, something seems a little funny. Back up. I want to see what we did on the last one. Not that. Done. Come on. No. Because 24 is the middle side, yes? What's the middle side for XYZ? Not 30. This will change it because common factor between both of these here is 12. 3. Yeah, because we would have our 26 with 39. 24 and 36, and the last one is 20 over 30, which reduces to 2/3. So again, matching those sides up correctly is important. Biggest to biggest, smallest to smallest, middle to middle, and it's all about how they relate to their specific triangle. So what that tells us is that triangle MLN is similar to, so we started here, I went along smallest and then biggest, yes? So over here, smallest is 30, biggest is, and I want to follow that same pattern, yes? Smallest, biggest. So where would I need to start? To go across smallest, biggest, so Z, Y, X. Questions on this here?